Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math, No Calculator section, question number 8. Alright, here they've given us an equation up top. It says n times a equals 360. Okay, and then they're going to give us an English language explanation of this. And oh my god, this English language explanation is a doozy. It says the measure a in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. That's classic SAT confusing stuff. But here, let's just break it down. What are they trying to say? Well, they're saying that A is this thing. It's the measure of an exterior angle. A is how big an exterior angle is. What is an exterior angle? I don't even care. It's A is what it is. And A is related to the number of sides that the polygon has. This is the number of sides is n by the formula above. Here's the number of sides times A, the exterior angle. That's going to be 360. The number of sides times A, it's 360. Okay. If the measure of an exterior angle of a regular polygon is greater than 50, what is the greatest number of sides it can have? All right, now, one of the ways to do this question is to understand what they're talking about in English. That I think would help. You know, you could imagine a polygon, you know what an exterior angle is, you can imagine the number of sides and stuff. But I'm not going to explain it that way because I don't want to force you to count on that. Instead, I want to explain it just through translation. Raw translation from English into algebra. And we're going to solve this question in algebra. I'm also going to show you another way, just guessing and checking. You need to understand what we're going to try to, like what our goal is, and then we're going to guess and check, see how we can, if any of these answers help us achieve our goal. So here's plan A. Plan A is involved, well, both of these involve translation from English into algebra, and then plan A involves doing algebra, plan B involves guess and check. All right, so let's look at this translation piece first. Here, we're gonna just parse this paragraph again, and we're going to take this English language information we're given and translate it into algebraic information. So here, the first thing, this A is greater than 50. This is from this sentence here. If the measure of an exterior angle of a regular polygon is greater than 50. Now that, I don't even understand it as I read it. But the important thing is not to understand what its meaning is in English. The important thing is to understand that they are talking about the A thing. A, we've already been introduced, is A is the measure in degrees of an exterior angle of a regular polygon, right? An intentionally long and difficult seeming phrase, but that's just what A is. A is the exterior angle of a regular polygon, right? So if they're talking about the measure of an exterior angle of a regular polygon, this is A, right? This whole thing, that's just A. And they're saying A is greater than 50. So here's the first piece of translation, right? We've taken what seems to be a confusing long English sentence, and we've broken it down into an easily workable algebraic expression. A needs to be greater than 50. The measure of the exterior angle of the regular polygon needs to be greater than 50. A is greater than 50, right? And then the second part, this max n equals what? That's from the second part of the question. What is the greatest number of sides it can have? And here, this comes from here, this number of sides. They've told us that the number of sides is n. Right? So that's n is from this equation, and the number of sides is n. And then here they said, what is the greatest number of sides? So to translate the question they're asking, they're wondering, what is the maximum n? We want n to be as high as possible. What's the highest number that we can have for n while a is greater than 50? So we're going to use these two new pieces of algebraic information and combine it with this piece of algebraic information that we're given initially, this equation that relates n and a and 360. So again, our three starting pieces, and notice I'm not going to talk at all about polygons or what polygons are or what exterior angles are. I'm just going to talk about these raw equations, these algebraic equations. Here, n times a equals 360. That's piece of information number one. A is a thing that's greater than 50. That's piece of information number two. And piece of information number three is we're trying to figure out what n needs to equal, right? What is the highest that we can get n? And so here's plan A. We're going to use algebra. And really what this is going to be doing is combining this piece of information, a is greater than 50, with this piece of information, this equation. These equations both involve a. So we're going to isolate a and substitute in this greater than 50 thing for whatever a is equal to. And here I'll just show you briefly how that works. Here, the first step, this is just us rewriting the equation above, right? Way up top it says NA equals 360 degrees. and we're going to move the n over to the other side. We're going to divide both sides by n so that we get a alone. Here's a alone right here, right? A, turns out, equals 360 degrees over n. That's just algebraic manipulation of the expression above. Now, the reason why we did that is because now that we have a alone here, we have two expressions that both directly involve a. We have a is 360 degrees over n. We also have a is greater than 50. So we can substitute this 360 degrees over n, which is the same thing as a, into this expression. So here, that's where this step comes from, right? This was a is greater than 50. This did say a is greater than 50. But instead, we're substituting in 360 over n in for a, because we know that 360 over n is a. All right, so 360 degrees divided by n, that thing, whatever that thing is, needs to be greater than 50, because that thing is a, and a needs to be greater than 50. Okay, that's the hard part. This is like, if you get here, you've done the hardest part of this question right. The rest is just algebraic manipulation. We're going to get n alone, and this is going to tell us, n needs to be greater than a thing, and then it's going to give us the answer from there. So getting n alone is just a couple-step process, right? We need to put n on top first, so we're going to multiply both sides by n. We're going to take n and move it up here by multiplying both sides by n. So we're going to end up n times n is 1, so that's just 1 times 360. It's 360. And this is going to be greater than 50 times n, right? Because we multiplied this side by n, multiplied this side by n. 360 degrees is greater than 50n. Right? Now we're going to need to get the n alone, so we're going to move the 50 over to the other side by dividing both sides by 50. So that's what's going on here, right? 360 degrees divided by 50, that's going to be greater than n. Another way of thinking about this is n needs to be less than whatever this is. So now we just need to do this fraction. This is 360 divided by 50. Well, that's the same thing as 36 over 5. Here we're dividing both sides by 10. Or another way of thinking about it is just canceling these zeros out, right? 360 over 50, that's the same as 36 over 5. So here we reduce the fraction. 36 over 5 is greater than n. And then we're just going to do some long division. What's 36 over 5? I mean, can you know what that is in your head? Here's the long division for it, but it's 7.2. Here's 36 over 5. Well, 5 goes into 36 7 times, and that's 35. So 7 times 5 is 35. We're going to subtract. That's a 1. This 0 comes down. Oh, this is 36.0. The 0 is going to come down. How many times does 5 go into 10? 2 times, so it's 7.2, and there's no remainder. All right, well, doesn't matter exactly the number that you figure out. I mean, it does happen to equal 7.2, and that's right. But once you get like 7 point something, it's like 7 remainder something, we know that the maximum value of n is like a little bit more than 7. It's 7 point something. Who cares if it's 7.2 or 7.9? The reason why this decimal doesn't matter is that n is a number of sides. This is what n is tracking, is some number of sides, and it's a whole number. Another way that you can get that hint is that all of these answers are in whole numbers. This is not like 7.2 here and 7.6 here. All of these answers are given in terms of whole numbers, and the reason why is because we're tracking number of sides. Polygons, shapes, don't have 7.2 sides. There's no like 3.5 angle. There's only triangles and rectangles. So here, n needs to be less than 7.2. So the biggest whole number that n can be is 7. Right? It could be 6, that'd be a thing, but that's not the biggest it could be, because it could be 7. 7 is less than 7.2, but it can't be 8, because 8 is more than 7.2. Instead of less, it needs to be less. All right, so the max n is 7. That's the max number of sides that this regular polygon can have, and that's how you get to answer choice C. All right, now that's kind of hard. I would call it medium difficulty, hence this sort of question number 8. And if you are having trouble getting there, if you're having trouble doing this sort of algebra, or you've gotten caught in the English language stuff, I would say the other way of thinking about it is guess and check, right? You want to hone in on what our goal is. What are we trying to accomplish? What are they asking us for? And then see if these answer choices fulfill that goal. So this is where this paragraph comes in right here. Here, this is plan B, guess and check, and it says we want to max out n, right? We want n to be as high as possible. We want the greatest number of sides. We want n to be as high as possible while keeping a greater than 50, right? And this is from if the measure of an exterior angle of a regular polygon is greater than 50, right? The measure of an exterior angle of a regular polygon, that's a. A is the measure. So we want a to be greater than 50. We're going to keep a greater than 50. So we're going to try the highest option. We want n to be as high as possible. Let's try 1 billion, If 1 billion works, then, oh man, we need to try something even higher. But 1 billion isn't one of our answer choices. The highest numbered answer choice is 8. So if 8 works, well, then that's going to be the right answer. Because if 8 works, then 7 and 6 and 5 are also going to work. If 8 works, it's going to be the highest of these that works. But if 8 doesn't work, then we're just going to work our way down. We're going to keep trying these until one of them works. That, I think, would be the way of going about it. You're trying to find the highest n. We'll try the highest one, and then try the next highest one, try the next highest one, pick the one that works first. And here, works is keeping a higher than 50. And we're going to see how that, like what works and doesn't work means when we look at answer choices D and C. So here we're going to try answer choice D first because that's the highest potential value of n. And so the first thing we're going to do is we're going to take this equation up here, and we're just going to substitute in D's option. Here n is 8. We're going to substitute in that option for n. So here instead of NA equals 360, this is 8A equals 360. We've substituted 8 in for n. And now we're just going to solve for a, right? So a is going to be, we're going to divide both sides by 8. A is going to be 360 divided by 8. Then we need to do a little bit of long division. What's 360 divided by 8? Well, 8 goes into 36 4 times. 8 times 4 is 32. So 32 minus 36, or 36 minus 32, that's 4. The 0 drops down. This is a 40. 8 goes into 45 times, and that's a remainder of 0. So 360 divided by 8, that's 45. Okay, so A is 45. Well, A needs to be greater than 50. That's like our one thing that we care about. A isn't greater than 50 here, so this doesn't work. That's what not working looks like. You don't need to fully understand this whole problem in order to be like, okay, I've kept track of this. Our two requirements are this and that. So here, if n is 8, well, apparently that's too high because n being 8 makes A too small. It makes it 45. So this is the last step here. Realize that D is wrong. Cross that out. Move on to answer choice C. And then answer choice C looks pretty similar to this, but we're just checking to see if it works, right? We're doing the same thing, substituting in 7 for n now. Let's see if 7 works. If it does, it'll be the highest one that we have. It'll be the highest option that works. So 7a, instead of NA equals 360, we've got 7a equals 360 because n equals 7. Then we're going to divide both sides by 7 to get a alone. So that's 360 divided by 7. That's a. So we need to do, again, some long division to figure out what this actually is. And so we're going to do this. Okay, so 7 goes into 36 5 times. So here's the 5 times 7, that's 35. And then 36 minus 35 is 1. And then this 0 from the 360 drops down. Well, 7 goes into 10 one time, so that's 51. And then we're going to go down, so that's 1 times 7 is 7. 10 minus 7 is 3, so now we got a 3 down here. And now we basically need to figure out, okay, like, at this point in the long division, we know that the answer is 51 point something. It's going to be, and if we want to do this, it's what? This is going to be a 51.4 because 7 goes into 34 times a 51.4, and then there's another remainder. You can keep going, but you don't have to. We know that A is 51 point something, and that's enough because 51 point something is higher than 50, and that's what we care about. Again, the thing that we care about is that A is higher than 50. 51 point something, that's higher than 50 regardless of what that something is. So at this point, you know that answer choice C works. You also know that it's the highest one that works because this one didn't work and this one does work. And these two, even if they do work, they're lower than this one. So this is going to be the highest one that works. All right, 2 ways of doing the question. Thank you all for your attention, and I'll see you in the next video.